We'll solve this by using two facts. First, the radius is the distance from C' to A, which we can find with the distance formula. Second, if the central angle AC'(B) is 90 degrees, then the chord AB equals our times square root of 2, which comes from the chord formula. The radius is the distance from C' to A. Distance formula. The distance between 2 points, x1, y1, and x2, y2, equals the square root of the quantity x2 minus x1 squared, plus y2 minus y1 squared. Here, C' is h, k, and A is h plus 1, k plus square root of 102. So R equals the square root of the quantity h plus 1 minus h squared, plus k plus square root of 102 minus k squared. That simplifies to the square root of 1 squared plus the square root of 102 squared, which is the square root of 103. Now use the chord formula. For a central angle theta, the chord length is 2 arc times sine of theta over 2, with theta equal to 90 degrees. Chord AB equals 2 arc times sine of 45 degrees, which simplifies to r times square root of 2. Substituting r equals square root of 103 gives AB equals square root of 103 times square root of 2, which is square root of 206. The key idea is that a right central angle makes the chord equal to r times square root of 2. So once we found the radius, the chord followed immediately